So continuing the 4-4 notes, right here there are some visual representations of two things. We've got which trigonometric ratios are positive or negative in which quadrant. There's no way I'm memorizing this picture. I mean, you could take like a mental picture, click, but there's easier ways to know it without having to memorize it. Okay, I'll tell you about that in a moment. And then over here is for reference angles. And I do not have this memorized. You are more than welcome to memorize it. I don't have it memorized because for me personally, if I know that this angle here is 120 degrees, then for me it's really easy to find out that this right here has to be 60 degrees. I can like common sense kind of figure that out. I don't need a formula to tell me take 180 minus the angle to equal the reference angle. If you need that formula, you can memorize them. You will not get them on a quiz or a test, like you would just need to know them. Today it's going to be more like if this is 30 degrees, what's that angle? 150. See, we don't need a formula for that, I hope. Some of you might, but just letting you know it's there if you need it. Okay, going back to what's positive and what's negative in which quadrant. We kind of talked about this a little bit, that sine rhymes with y, right? Sine is y. Cosine is x, and tangent is y over x. And then we talk about, where is y positive on the coordinate plane. Right? Y is positive up. Cosine, so that's sine, where sine is positive. Cosine is x, so we talk about where is x positive. Well, x is positive to the right. And the tangent is y over x. For tangent to be positive, both y and x have to be positive, or both y and x have to be negative to give us a positive. So tangent is positive in 1 and 3. So these are the quadrants at which they are positive. So if they are not positive, then they would be negative in the other quadrants. Right? There's not a third option, is there? I guess 0 would be right on the, so I guess there is a third option. Okay. When I talk about sine, cosine, and tangent, if we reciprocate it instead, I'm not talking about sine, but I'm talking about cosecant. It's exactly the same sign when you reciprocate it, so I don't even think about those. There are some sayings to help you with this, but I don't really use the sayings because I'm not the kind of person that needs a saying to understand math. I already know that y is positive this way, and I know that sine is y. If you need the same, then some people will write all, like everything's positive in that quadrant. Sine is positive in this quadrant. Tangent is positive in this quadrant. And cosine is positive in that quadrant. So I've seen two different things. I've seen cast. And then all students take classes is another way that I've seen it. All students take classes. If that helps you, great. But I'm not a gimmick person, because if you know the gimmicks and you don't know the mathematics, and not knowing the mathematics is going to hinder you when you get to AP. So I would focus on the mathematics. If you forget for a second, you're like, oh my gosh, what happened? Then you still have that. All students take calculus. Okay? Or classes. It's both, but not all students take calculus, so that's why I don't say that in my pre-calc classes. This, you guys will all take it. But my other classes, not everybody takes it. Okay, so we've got finding the solutions that make the statement true. So this is what I had on the board before we started the video. We're going to find the solutions that make the statement true. Give the answers in degrees and radians. So we're going to do both. When you actually do this, I'm not going to ask for both. If it's a review, maybe, but if it's like a quiz question, I'm not going to ask for you to do both. I'll ask you to do one or the other. Just got to read the directions. So cosine theta equals negative radical 3 over 2. There's kind of like a 3-step process, maybe, that I go through. First thing I do is I notice that this is a negative number. So if it's a negative number, then I just say, where is cosine negative? Well, cosine is x. Where is x negative? 2, 3. Okay. So we've got some angle in 2 and some angle in 3. That makes a right triangle. We've got angles in 2 and angles in 3 that make a right triangle. And I put a little theta in there. That little theta that I put in there would be the reference angle. Next thing I do is I say to myself, what is the reference angle? What is that reference angle? So I say, which angle would give me a cosine of radical 3 over 2? Well, I know it's got to be 30, 60, 90 triangle. So I'm at 30 or 60. I know that the sine of 30 is a half. So the cosine of 30 would be radical 3 over 2. So it's 30. My reference angle is 30 degrees. So the reference angle is inside of the triangles. So here, this is 30 degrees. And over here, this is 30 degrees. The question is not, what's the reference angle? The question is, what are the actual rotated angles to give me this terminal side that when I take the cosine of that angle, this angle right here, when I take the cosine of that angle, it will give me negative radical 3 over 2. So if the reference angle is 30, what is that red answer? 150. If, change my color. I don't have that many colors to choose from. Blue. If we start here and we go all the way down into the third quadrant, what angle has a reference angle of 30 degrees but in the third quadrant? 210. So that would be my two answers. However, that's if I go around one time. Could I have gone the other direction? Could I have gone clockwise? If I went clockwise, it would be negative 150 and negative 210. Could I have gone around twice? How do you make a coterminal angle? If I know 150 is an answer, how do I make a coterminal angle with 150? We add 360 to it. So if I'm taking that 150 and I'm adding, actually let me do it this way, 360, how many times can I add 360? A lot? A lot? Could I add it 1.5 times?
No.
How many times could I add it? And get the same answer. How many times could I add 360 and get the same answer? The answer is a lot, but it is not every number. Ian?
Every integer.
Any integer. Including, yeah. So that'll include negatives. Would that include 0? Yeah. Yeah. Okay. So maybe I would do like 360n. Same thing with 210. We could do 210 plus 360n, where n is an integer. That would give me all my solutions. Yeah. How about radians? So that was degrees. Same question, transition. Let's do radians. What would the reference angle be in radians?
5 or 6.
So be pi over 6. So we're looking at the pi over 6's that are in the third quadrant, second quadrant, and third quadrant. Just a reminder, every pi over 6 that's in a quadrant is a pi over 6 that does not reduce. So it won't be any even pi's over 6s. It won't be any multiples of 30 pi over 6s. What's the pi over 6 in second quadrant?
5 pi over 6.
5 pi over 6, third quadrant.
7 pi over 6.
7 pi over 6. See? Now, is that all the answers? So in order to find all the answers, we would take that 5 pi over 6, and what would we add to it?
2 pi.
2 pi n, where n is an integer. I'm not writing that over and over again, but it's there. Okay. And we would have 7 pi over 6 plus 2 pi n, where n is an integer. You just need to specify that it's an integer because otherwise it could be any number, and that's not exactly it. Okay, so now I'm going to change the directions. I've gone over how to do all of them. We're not going to do all of them. I'm going to add in something to the directions that says for degrees, we're going to only do answers that are greater than or equal to 0 degrees or less than 360. And for radians, I'm going to change my directions that say 0 less than or equal to theta less than 2 pi.
So on the test,
Yep.
if it doesn't say something specific like that, then we need to do what you did.
If it doesn't specify, you should. Yeah. Now I'm trying to think right now about those practice ones that I gave you. I can't remember. I know it says it on the ones that I made up, but the ones that I just took from the internet, I'm not sure what it says on there. I didn't give you any that are like this yet.
So what we need to do that on the test eventually?
If I put it on the review, then it could be on the test. Okay, you see it in the review. This is the first day we're doing this. I didn't give you any that are like this. Now, I will tell you there is one reason why I definitely brought this up is in chapter 4, second half, when we start graphing sine and cosine, we start taking, and I don't mean graphing a circle, but I mean like taking that and graphing it on an XY plane a different way, we will need to understand this. So that will come back into play. That's going to be more important for what's coming up, not so much for what's next week. Okay? All right, cotangent theta equals 1. So we got to figure out where cotangent theta equals 1. So I'm going to start. I'm a visual person. I need to see where cotangent is positive. So cotangent is x over y. And you know what? If you don't like cotangent, we can change it into tangent. How do I change it into tangent? So the reciprocal of 1 is just 1. So if you want to use the reciprocal function, these are the exact same answer. Where tangent theta is 1, cotangent theta is also 1. So where are these positive? 1 and 3. So I'm going to put a terminal side in 1. My little theta is going to be down there. And in 3. That looks like a little bow tie. So now I need to figure out the reference angle. So now I need to think about if y over x is 1, that tells me something about both y and x. They're the same. What possible triangle can I have that they are the same? 45. Okay, I got my reference angle. It's got to be 45 degrees. And for these, I don't know if you noticed, I don't have a calculator out right now. These would be the ones that are non-calculator. These are going to be the ones that you know, or should know. The 35, or sorry, the 45s, the 60s, and the 30s. Okay, those are going to be the ones we know. All right, so if this is 45 degrees, then my reference angle right here is 45 degrees. My reference angle right here is also 45 degrees. So now we need to know the terminal side. So if I start at 0 and I just go to right here, that is also 45 degrees. Sometimes the reference angle and the terminal side are exactly the same, only in the first quadrant. In the third quadrant, I'm going to go around into the third quadrant. I've got one reference angle into the third quadrant. What does that answer? 225. And then I'm not going to go around anymore because I just put a limit on how many times I'm going around. Could I use negative 135 for one of my answers, though? Could I use negative 135? Right. This says, nope, no negative answers. Thanks for trying. Okay? Now, in radians, my reference angle, radians. My reference angle would be pi over 4, good. And pi over 4 in the first quadrant is pi over 4. And if we count a bunch of pi over 4s all the way around to the third quadrant, it's a number over 4 that does not reduce. It's going to be 5, pi over 4. Okay. Now there's two next ones I want you to try. See if you can get them. All right, so I was walking. And I saw lots of you say, okay, sine positive in the first. In the second quadrant, because sine is y, so we go up. That's good. And reference angle. I know that sine of 30 is a half, so this can't be 30. It's got to be 60 degrees. So here's 60 degrees, and here's another 60 degrees. Since that 60 degrees is in the first quadrant, then that triangle also has to have a 60 degrees terminal side. And then in the third quadrant, 120 degrees. We change that to radians. Our reference angle is pi over 3. First quadrant, pi over 3. Second quadrant, 2 pi over 3. All right, and then the next question, I saw a lot of people sitting there like this. This one was a little bit trickier. I know that cosine's positive this direction. I know it's that direction. But cosine is x. And if it's on the unit circle, it's x by itself. And there's only one place on the unit circle where x can be, stop working. There we go. Where x can be 1. And that's right on the x-axis itself. That's the only place where x can be 1. Because if it's the unit circle, the radius is also 1. So it's the only place that it could possibly happen. So this is at 0 degrees or 0 radians. What would my reference angle be, though? Katie, do you know? There wouldn't be a reference angle, exactly. There is not a reference angle if it's 0 degrees or if it's 90 degrees. There is no reference angle. 2 questions.
Why would it, 360 degrees be an angle?
Good question. Natalie, is that your question too? Yeah. Well, remember I limited what we could answer. And I small. I don't know if you can see it all the way, but I said it can be greater than or equal to 0, but it only can be less than 360. So we're not actually repeating any answers all the way around. Because 0 and 360 are coterminal. Good question. All right, the last section is going to be the exact same stuff we did, only they are not special. So we have to use our calculator. Exact same stuff, but they're not special. Need to use our calculator. We are going to we're going to determine the value of theta to the nearest hundredth of a degree, hundredth of a radian, when sine of theta equals 0.3892. Now, I'm going to do something that, I don't know, I feel like it helps me understand this. And potentially could help us understand things that will come up in the future. I'm going to write the equation sine theta equals 0.3892. Okay. To this equation, what do I need to solve for? What do I need to isolate? Theta. Is this word sine being multiplied by theta? The answer is no. So I can't divide by theta. There's only one thing that will undo sine, and it is the inverse of sine. Inverses are what undo each other. So like multiplication and division are inverses. They're inverse operations. This is not being multiplied. So I use sine inverse. I'm going to do it to both sides of the equation. So to both sides of the equation, I'm using sine inverse. When I use sine inverse, that cancels out sine. That undoes sine, and I get theta. On the other side, I have sine inverse of 0.3892, and I know you guys know that's what we need to type in our calculator. Ooh, let's do degrees. We're going to do both. So let's just do it in degrees first. There we go. Now I can do it. So it's approximately 22.90473 something or another. Yes, dear. Yeah. Okay. I have a little graph over here, which I normally use first. I just don't know why I was so eager to get the calculator out. Before I use my calculator answer, on my little graph, that's just to sketch which quadrants it would be in. So we look at sine, and we look at the answer, and it is a positive answer. So which quadrants? Okay. And so that's where theta is going to be. My terminal sides are what I'm trying to find, that angle and this angle here. Those are the two angles I'm trying to find. Okay, so I got about 22.90. What did that just give me? I think I heard two answers in there. I definitely heard the reference angle. The louder people said the reference angle. But I think I heard another answer in there too. Was there something else that it gave us? It gave us the first answer. Because the first answer is in the first quadrant, so the reference angle and the first answer are the same. So it did give us the first answer. Oops, I forgot a 9. So now we need to find the other terminal side. This reference angle is that 22.9. I am not going to round that answer until the very end. So I'm going to use this calculator number, that huge number, where I need to. How can I find out if I know the reference angle is about 22.9? How can I find out the actual rotated blue angle here? I'm going to take 180 degrees, and I'm going to subtract. Now, I'm not going to subtract 22.9 on my calculator. I'm going to subtract the answer. Do you know how to subtract answer? There's a couple ways to do it, but I'm going to do 180 minus, and I do second negative sign, so it literally says A and S. I know I'm subtracting that last answer. With the newer calculators, you could do 180 minus, and then you can go up and grab that number and pull it down. Not everybody's calculator will do that. Everybody's will do this, so that's what I'm showing. And we get approximately 157 point. Emma, do you have a question? Oh. Do you know the answer? Rounding it to two places. Mm-hmm. And thank you for saying that zero. Be 157.10. You know, a lot of people say, well, the zero doesn't matter. Yeah, I know. But at the same time, if I ask you 2 decimal places, then you show me it's 2 decimal places. Because the same answer would be for 1 decimal place, but I didn't ask you to round it to 1. You know? Okay. All right, now we're going to do the exact same question, but with radians. And in your assignment, you won't have to do both radians and degrees. It'll be like one chunk that says, do all this in degrees, and another chunk that says, do all this in radians. But there's only 3 questions, so we'll do them both. So to do in radians, I'm going to do all the exact same stuff I just did, but I'm going to do something with my calculator first. Just change my mode. So you can, even if you have the older calculators, you can pull up that last question. Oop, come on. There we go. You can pull up this sine -1, sine inverse question if you don't want to retype it in by hitting second enter. If you don't want to retype it. So I did sine inverse of 0.3892, and I got, we got to do 2 decimals. What's 2 decimals going to give me? Page, yeah. 40, yeah. All right, and then that is my reference angle. It is also my first answer. And then my second answer before, you can see my work from before, we did 180 takeaway answer. That's not going to work this time. That'll give you a way wrong answer. I need to do what? Pi minus answer. You know, if I have to say it out loud, it's probably happened before. So, you got to make sure you don't use 180 when you're in radians. So, 2.74. Radians are a little bit more challenging because we're not as familiar with radians and where they are. So a lot of times I will go put like 0, 2 pi, or maybe just put 6.28. I'll put 3.14. Up here is 1.57, and down here is 4.71. Just so I can make sure when I get an answer of 2.74 that it really is in between 1.57 and 3.14. I will get answers on quizzes and tests that are like 7.29. And if you get an answer like 7.29, you've done something wrong because the highest answer I could possibly get would be 6.28. And it's just like forgetting how to find, you'll see, we're going to do it in a moment, but just forgetting how to find like an angle in which quadrant. Do I add 180 degrees or do I subtract 180? It's like doing things like that. We just forget things because they're similar. All right, so this next one, I don't want to do degrees and radians every single time. That's just silly. Let's just do this one for degrees, okay? Let's do this one in degrees. So I'm going to start by saying this is secant. And secant is the reciprocal of cosine. Would cosine theta have the exact same answer? No. What answer would cosine theta have? Oh, hold on. I need some more space, so I'm just moving this real fast. So 1 over this number, somebody went ahead and took the number, put it in front. That's even better. We don't need to get that exact and simplified because this is not like an answer. It's just me saying to myself, secant is the same thing as cosine, and cosine is the reciprocal of whatever that number is. Okay. So where is cosine or secant negative? Left, 2 and 3. Their reference angles are going to be the same. So how do I type it in my calculator? Is there a secant inverse button on the calculator? There is not. What inverse button do I have? Cosine. So the fact that I reciprocated that already, that was actually my first step. We do not have a secant inverse button. We have a cosine inverse button. So my equation is going to actually be cosine theta is equal to 1 over negative 2.3412, or pull the negative out if you so choose. But it's just it's just part of the problem. That's why I'm not simplifying it. So I have to use cosine inverse. That's going to cancel out cosine. That's going to give me theta. Who's abusing their calculator over there? Why? Okay. Has it not been good to you? Is that what's going on?
Yeah. It wasn't radians on my physics test.
Oh, no. Did I mess you up a bunch?
I don't know. We'll find out.
Okay.
I mean, my teacher's nice, so we don't think.
All right, so I got about 115.29. Is that the reference angle? No. The reference angle has to be less than 90, so what is that number? That's our first answer. You see 115? That's in the second quadrant, right? Yeah, that's the first answer. So let's see. So 115.29 degrees is our first answer. Oops, come on. So how do we get the other answer? I could think of it ways. How do we get the other answer? Megan? Like the 115 plus 180? Okay. So that's going to be 295. This is 270. Did that work? It didn't work. So you see how I'm like talking about where the quadrants are and just kind of making sure? It's easy to see that with radians. No, degrees. People make the mistakes on radians. That's where they make the mistakes. Natalie?
You can subtract the 115 degrees from 180
And why are you doing that?
because if 180 degrees is your entire x-axis, then you subtract that.
So we are finding our reference angle. That's what you're doing. She said, let's find the reference angle. Let's find that little pink thing. Okay? So the reference angle, we do 180 minus our answer, that 115. We get a reference angle of 60.71-ish. But that's not my second answer. So now what can I do to get my second answer? Now I'm going to, and I'm doing this on the calculator. You can see side by side. I am not rounding ever till the very final, answer. So now I'm just doing plus 180, and I get 244.71. Does that seem appropriate for that quadrant? Okay. So I'm going to do plus 180 to get that 244.71. And then I'm going to tell you there is another way we could have gotten that answer. There is another way I could have gotten that answer. Do you know, Kylie?
Yeah, or I did it a different way.
Yeah.
But you had the 115.
Uh-huh.
So then what I did is I did the reference angle times 2 because there's 2 of those, and then I added it to 115.
You added it to what?
115. So you're trying to find the 2, so there's 2 reference angles.
Oh, I see what you're saying. Now, I would not have thought about doing it that way at all.
I don't know, I saw that first because of the picture, so then I
So you still found the reference angle.
Yeah.
Okay, there's another way of doing it without even finding the reference angle. Your way works. Okay, I just never in 5 or 6 years have heard anybody say it that way. What do you think, Taylor? Yeah, if you took 360, which is a whole circle, and then we went backwards 115, that would also end up in the right place. So that would be another thing if I did 360 minus that 115, 244.71, so same answer. So either way is fine. Whatever works for you, you can create it right on the spot. That's why I don't like having that formula for the reference angle, because I feel like we look at things differently sometimes. Okay, third one let's do in just radians, and then we are done for notes. I'm going to stop talking for a second because I want you to see if you can figure out how to start it, besides putting your mode in radians. I drew a picture first. I don't know if anybody else did that. That's what I did first. You have a nosebleed?
Yeah, can I go nosebleed?
Yep, go. Oh, wait, bathroom? Where are you going? Where are you going? One second. Stay. Sorry. Okay, so then I did sine theta is 1 over negative 8.1037, because that's the only way I can do sine inverse, is to have it say sine. All right. Did you get that answer? Is that our first answer? Is that our reference angle? No and no. So the calculator, what it gives you is not the first answer every single time. It is also not the reference angle that it gives you every single time. We're going to learn what it gives you in a different chapter. Not chapter, section. In the future. We're going to learn what it's giving you. So that's why I'm drawing a picture every time, because it doesn't always give me the same thing every single time. So if I get a negative 0.123, that is telling me from 0, we're going this way, 0.123. So it is giving me this terminal side, but it's giving it to me negative. And my directions, which are not on this paper right now, but they do specifically say that we are going to give answers that are positive. So this can't be my second answer. It can't be one of my answers because it's negative, but I can find a coterminal with it. How do I find something that is coterminal? Add 2 pi. So if I take this answer and I add 2 pi, it will go all the way around once, and that will be the second answer. And we're rounding to do 2 decimals, so I got 6.16. Now, I do want to double check and just kind of make sure that my answers are making sense. So this would be 0 or 6.28. This would be 3.14. Up here would be half of that, 1.57. This one at the bottom, if you add 3.14 and 1.57, you get 4.71. So does 6.16 seem appropriate for the quadrant it is listed in? Okay. How do we find the first answer? Awesome.
What it is, I subtracted 6.16 from 2 pi, which gave me the reference angle, and I added that to pi.
Okay. When you subtracted 6.16 from pi, or 2 pi, from 2 pi, so you said?
Yeah.
When you subtracted those, what did you get? What number?
Our first answer was positive.
Right. So if you realize that this first answer is negative, however, without the negative sign, it is the reference angle, then we do have our reference angle. It just isn't negative. So our reference angle is that approximately that 0.1237. And then Austin said just add pi onto that, and we should have our second answer. Now, I don't like to retype things. I like to keep things as accurate as possible. So I'm like going to manipulate this a little bit. Let's see. If I have the old calculator, what I would do if I had the old calculator is I would just get this number again and then perhaps multiply it by -1. I'm good, now it's positive. And then add 180, or not 180, not 180, add pi. So I can not have to retype in anything. Yeah. No.